Hi everyone, I'm Paul Okeumi, a data scientist and a lover of agriculture. On regular basis, I plant food crops like corn, pepper, tomatoes, potatoes in my backyard. This small scale farming has really helped the family to save money and has reduced the number of times we visit the market. So oftentimes the crop grows to the point of harvest, but unfortunately sometimes they get eaten up by plant diseases, common plant diseases. This is where I draw the curtain open and I present to you Plantnosis. Plantnosis is an AI plant diagnostic tool. From the word you can already tell from merge from both words, plant and diagnosis. This tool can be accessed via your mobile device or the internet. So you just whip out your mobile device, take a picture of the plant affected plant's leaf, and immediately you get the plant disease as an output. And going a step further, you get treatment suggestions. So this tool will help someone like me a whole lot, someone who doesn't know anything about these plant diseases. And this also helps small farmers like subsistence farmers to accurately detect plant diseases and suggestions for pesticide usage. This in turn will increase their yield a whole lot. So how do they do this? Bringing us down to the methodology. So here the problem can be modeled as a multi-classification problem we exploit the use of convolutional neural networks, aka CNNs, which is considered state of the art for image processing. Like any problem involving AI, you definitely need data and you need lots of it. So for this project, we trained on over 30,000 images of healthy and unhealthy plants, leaves, spread across 19 classes. So in order to capture other classes we are not interested in, we introduce a new class unknown. So altogether making 20 classes. Because images were captured in a confined environment, so we needed to do some augmentation slash pre-processing. So one, we changed background for random images, and two, we did some carried out some augmentation techniques like random rotation, random flipping. We changed the brightness so as to denote different times of the day, e.g., in the morning when the sun is very bright, in the evening when it's not so bright. We did something like sharing our warping, which means denoting different camera angles depending on the user. So to achieve excellent results, we needed to use transfer learning. We leverage the use of transfer learning. So this brings us to our model architecture. So by simply fine-tuning a pre-trained model, in our case, we used the exception model, the exception architecture. In total, we had 31 million parameters, but training was done for free via Cargo Kernel. So this brings us to our results. So after training for about 30 epochs, we were able to achieve an accuracy of 85%. Considering that this model is to be deployed on mobile and other edge devices, it needed to be very small and be very accurate. So this is not a bad result at all. So here you can see a mock-up showing the website, and you can see our mobile device, our mobile app. So you can either upload from your gallery or take picture in real time. In conclusion, plant disease is an ongoing challenge for smallholder farmers, which threatens their income and food security. Like written in my introduction, Nigeria is just seventh in agriculture in Africa, behind South Africa, Kenya, amongst others. And currently, the existing method for plant disease detection is naked eye observation. With the aid of tools like Plantios, can greatly impact our agricultural sector and the economy in general. This also translates to solving SDG goals 1, no poverty, and SDG goal 2, zero hunger. Thank you for your time and thank you for listening to me. The Plant Gnosis team consists of agricultural experts software engineers, and data scientists. Thank you.